Hello everyone. In today's discussion, we will be seeing a topic from Module 4, that is water chemistry. Under water chemistry, the topic is boiler feed water, and we will be discussing about the boiler problem, that is scale and sludge formation. After the completion of this session, the student would be able to define the terms boiler feed water, what is scale and sludge, explain the reasons behind the same, write the relevant reactions involving the scale and sludge formation, list the disadvantages associated with the process, also quote some of the overcoming measures with which the scale and sludge formation could be minimized. Let us now begin with the introduction to water chemistry. Water chemistry is that branch of chemistry where we deal most of the analytical discussion related to water. As we all aware about the importance of water, which is considered as a must for our survival. Further, water finds very much useful, or its application is very wide, especially in the field of industry. So here in this module we will be discussing about water as used as a important element for the industry, the problems associated with the same, and overcoming measures as the first part of the module. In the next part we will be discussing about sewage water and the problems with the sewage treatment, and some of the analytical methods to convert the sewage water to the drinking water or potable water. Also, at the last part of the module, we will be seeing some methods to improve the quality of water, that is like demineralization or reverse osmosis, and some analytical approach where any contamination in the water could be detected. Now let us now begin with the introduction to water chemistry. So as we all aware, water could be accessed from two different sources, as like surface water and underground water. Surface water is available in the form of rainwater, river, lake or sea water. Similarly, underground water by well water, tube wells or the springs. Now the water so available from the environment is used in industry for various purposes. In order to study about boiler feed water, we need to have a broad classification of possible impurities in water. Though we know what are the impurities present in the water, let us see chemically how we can classify them. So first set of impurities could be classified as dissolved impurities, where here we are having the dissolved salts or gases. They may be bicarbonates, chlorides, sulfates or gaseous substances like oxygen, carbon dioxide, hydrogen sulfide and ammonia. The second category could be the suspended impurities. Now here they include actually particles like sand or silica, sometimes the hydroxides of the metals. Here specifically we have mentioned hydroxide of iron and aluminium, the commonly used hydroxides. Also we may have some organic suspensions, that is nothing but decaying vegetable matter, or they are formed due to the microorganisms. The third possible impurities is colloidal kind, where they will be present in a finely divided state. They may be sand particles, clay or any coloring material. Actually these colloids, as we have studied in the lower classes, they would be giving turbidity to water. Then fourth class is biological impurities or microorganisms that could be present. They are like bacteria, fungi, algae, etc. Now the water which we use in industry for various purposes must be free from all the above said kind of impurities. That I mean the dissolved impurities, suspended impurities, colloidal impurities and microorganism impurities. No kind of impurity must be present when we take the water for the industrial usage. Now let us begin with the topic, the boiler feed water. So here one important feature of water is made use of. As we aware, as we know, that is water on heating get transferred into its vapor or steam. So what could be done here in the industries? This particular factor is made use of, and this steam is produced, and we know that produced steam could be later used for the power production. So any setup that is used in the industry for the production of steam we call as boiler, and the water which is fed into the boiler is called as boiler feed water. So here comes the definition of boiler feed water. Water which is fed to the boiler in order to generate the steam is called as boiler feed water. And here one more point to be remembered, by chance if any contaminated steam or water is used in the boiler, that is going to create lot of problems. We call it as boiler problems. Now let us see the requirements of a boiler water. If that requirement standard is not met, what could be the boiler problem created? So herein you can make out, the first one is water must be free from hardness causing salt. If it is not free from hardness causing salt, then it would cause a problem what we call as scale and sludge formation. Second major expectation is there must not be presence of any oil or greasy substance. If not, then it is going to create one more problem. We call it as priming and foaming. Then third is it must be free from any kind of salts or suspended impurities, failed which it is going to create a caustic embrittlement. And the last one, it must be free from the dissolved gases or suspended salts, this particular criteria. If this is not met, it is going to create boiler corrosion. Of the 1 to 4 we will be discussing in curriculum the problem 1, 2 and 4, that is scale and sludge formation, priming and foaming and boiler corrosion. Yes. Now let us go for the topic scale and sludge formation. Let us now see on the broad spectrum why this particular scale and sludge formation takes place in the boiler. So here some imagination is required how the process is going on. Imagine we have taken the water and we go for boil the same. Okay. So how the process is done? The water is heated continuously under high pressure. Now what happens, because of which bubbles will be produced by default, and these bubbles are carried away and they will be striking the walls of the boiler. How it is? We take the water in the boiler and we boil it. The bubbles created on the surface of the water will be carried away and they will be striking the walls of the boiler. Now what must happen? There it must undergo evaporation because boiler body is too hot. So this bubbles will be undergoing evaporation, in the sense water present in the bubbles will be evaporated. So the dissolved salt, if any salt by chance is present in water, they will be undergoing, or its concentration would be continuously increasing on the walls of the boiler, and when the saturation level is reached, they would be undergoing precipitation. So let me summarize here scale and sludge formation. So first we will be taking water, we will be boiling, which create bubbles, and these bubbles are carried to the walls of the boiler where they would be broken, and due to the excess heat present there, the water content also get evaporated, leaving behind only the salt. When the concentration of the salt exceeds, they will be precipitating as a mass. So this is the cause, or I can say generalized cause for the formation of scale and sludge. Now let us define them. Now there is a small difference. I said salt precipitates. Now how it precipitates makes the difference. That is, if the precipitate formed as hard, thick, adherent, and it gets coated on the walls of the boiler, then we call it as scale. That is a very thick, hard and adherent. It is not easy to remove them from the wall, and it gets it gets coated on the walls of the boiler, we call it as scale. Suppose the so formed precipitate is loose, slim and non-adherent, easily it will be like floating kind, then you call that particular as sludge. So these definitions are important as far as exam point of view is concerned. Now let us see this diagram. This actually demonstrates the difference between scale and sludge pictorially. The first diagram what we see here, okay, that is this one, accounts to the formation of sludge. So sludge, as they have shown, will be suspended in the boiler because it is non-adherent, it is very slim and it is very soft. And on the other hand, the scale, as they have shown, is very thick, okay, and that will be very adherent and it will be sticking itself to the walls of the boiler. So this actually shows the pictorial difference between the two, that is scale and sludge. Okay, this is the realistic diagram how in the boiler sludge and scale are formed. The first one you can make out is floating kind of impurity, soft and slimy, is nothing but the formation of sludge. A very thick kind of deposition which cannot be removed easily, we call it as a scale. Most of the time scale formation we can see in pipelines and all in our everyday life as well. Now let us see the reasons for scale formation. On the broad view we have seen the theoretical explanation. However, how exactly chemically or by reactions the scale is going to be formed, we will be seeing here. Now here one point to be remembered is mainly the hardness causing salts are the reason for scale formation. Hardness causing salts might be familiar by your lower classes. Usually the salts of calcium and magnesium in the form of its chlorides and sulfates convert soft water to hard water. So in the sense, if in the boiler feed water we take hard water, there is a possibility of excess scale formation as well as formation of sludge also would takes place to some extent. Now let us see one by one the reasons for scale formation. So the first one is decrease in the solubility. What this stands for is certain salts, say for example the salt calcium sulfate. It's been observed that this particular salt is soluble in cold water. You take water, you put it to boiler, it is soluble. But as and when you reach a high temperature, slowly it would be starting getting precipitated. That's because there is a solubility change when you heat the water from cold to hot condition. Second important reason is chemical decomposition. Now what this stands is, many times the bicarbonate, this bicarbonate may be calcium or magnesium. Only one example I have quoted here, magnesium bicarbonate, that is MgHCO3 twice. Similarly you can take here calcium bicarbonate. What happens on continuous heating, they would be undergoing decomposition. And what is that conversion? The bicarbonate would be precipitated as corresponding carbonate. And what is the nature of carbonate? Highly insoluble. With that there would be liberation of carbon dioxide and water. However, here what to be remembered is the bicarbonate on chemical decomposition would be giving carbonates which would be undergoing precipitation in the boiler. So two reasons are clear. One is decrease in the solubility like calcium sulfate salt, which have a difference in the solubility to hot and cold condition. Also chemical decomposition of bicarbonates to carbonates. The third major reason is formation of silicates. Now here you can quote both calcium and magnesium silicate. Also they have the property like they are slightly soluble in cold water but too insoluble. Too much extent they are insoluble in hot water. They would be undergoing precipitation, and once silicate formation starts, then it would be progressively continuing throughout the boiler body. One more approach is hydrolysis, or one more reason is hydrolysis of the salt. So here we have taken the example of magnesium chloride, one of the permanent hardness causing salt, magnesium chloride. What happens when we continuously boil the water? Okay, the chloride salt would be undergoing hydrolysis to produce corresponding hydroxide, that is MgCl2 gets changed to MgOH twice, and this magnesium hydroxide would be again precipitating kind. So here also we have the precipitation of salt, which thereby lead to scale formation. So together, now let us summarize all the reasons for the scale and sludge formation. Okay. So one is decrease in the solubility, second one is chemical decomposition, third one is formation of the silicates, and fourth one is hydrolysis of the salts which are present. Now let us go for the next concept, that is the reasons of sludge formation. A small difference between the scale and sludge about their solubility is, it's been found that sludge is comparatively having greater solubility in hot water. Please understand this. That is, actually precipitation of the salt takes place, but comparatively it is soluble in hot condition. So automatically what happens? The next step takes place. The sludge so formed would be traveling to the colder part of the boiler, especially the distribution pipelines. I hope you are getting. In the main boiler body, precipitation takes place, but since they have greater solubility, they don't precipitate in the boiler main body. In turn, they will be traveling to the colder part of the boiler and they will be precipitating there. And some of the salt that may precipitate in that ways, the magnesium sulfate, whatever quoted here as third point, magnesium sulfate, magnesium chloride, magnesium carbonate and calcium carbonate also can cause. And the very problem with the sludge is, if we have not removed them, they are loose and slim, non-adherent, but imagine we have left it then and there only, then they will be slowly transforming themselves and they will be converted to scale on longer duration. Now let us see some disadvantages of scale and sludge formation. So first and foremost, it is decrease in the boiler efficiency. This we know because they are all bad conductors of heat. They would be obviously decreasing the efficiency of the boiler to convert water to steam. Second thing is wastage of fuel, and they will be making a coating on the walls of the boiler, or they will be depositing themselves in the boiler parts, and thereby more and more fuel would be consumed than the expectation. Third problem is said as danger of boiler explosion. This is an extreme case of scale and sludge formation problem. Actually what happens there is, the scale would be continuously depositing on the boiler wall and they will be becoming thick. Now continuously if you heat, that is a very bad conductor of heat, or I can almost call it as a insulator. Okay, I can call it as an insulator. Now this insulator slowly would develop some cracks in the structure. Scale would develop some cracks, and then water would be continuously boiling and steam will be produced. Now this steam, suppose this is the boiler body and here we have the thick deposition of the scale, and here some cracks are developed. The steam will suddenly enter to the cracks with very high pressure. And what is the state of boiler body now? This is under very hot condition, elevated temperature condition. So sudden penetration of the steam with high pressure would make the danger of explosion. Okay. Then fourth one is evident. Whenever scale and sludge would be depositing, one have to go for repeated cleaning process, and they are all expensive process because we have to interrupt the steam production, go for some advanced methods, and we have to restart the process. So cleaning expenses will be added on. Then sludge may have another problem which may block the pipelines or any boiler parts because it is going and depositing at the colder ends of the boiler. Now here I have kept a table which may make you a little bit easy to understand the concept of scale and sludge, because it actually compares both the concept. So once let us just go through the same. So sludge is caused due to heating, and the salt containing water will be concentrated, changes into loose and slimy precipitate, whereas if it is hard and adherent we call it as scale. And scale is harmful to boiler. Sludge is not harmful is written here, in the sense not directly harmful, but slowly it may become scale and make some harm. Then sludge can be removed from the bottom of the boiler time to time. Just tap off the sludge because it may slowly settle down and you can remove. But scale cannot be removed by either external or internal treatment. Can be removed by either internal or external treatment, or we may have to go for hammering. Just apply high pressure and make the scale to remove from the surface. Then sludge does not cause any clogging, or it may not lead the boiler corrosion, but scale will definitely cause the corrosion of the boiler parts. Then sludge would increase discarding cost of waste, but scale increases the maintenance and operation cost. Now let us see some overcoming measures. Specifically speaking, curriculum doesn't expect us to mention the overcoming measures, but as we have discussed a problem and we have discussed the cause of that, I have listed here some of the measures which could be easily understood and with which the problem could be overcome. So first and foremost, it is the periodic replacement of hard water by fresh water. Since we saw all the hardness causing salts cause the problem, if we replace hard water by fresh water, there is no chance of the boiler problem arising. So replacement of hard water by fresh water. Second approach is go for ion exchange method. Actually this is a method where hard water is converted to soft water. We have to do it externally, treat the water and then send. This particular process we would be studying at the end of the module very detailedly. There you would be getting more clarity about ion exchange method. The third one is go for mechanical hand scrubbing method. This could be understood by any common man, like how we remove the rust from the surface of the iron. Same way mechanical hard scrubbing method could be adopted. The fourth one is chemical method, where carbonate or phosphate conditioning is done. That's actually could be used for scale also, where we add one more chemical and they will react with the scale or sludge so that the product could be removed from the water. Then another approach is giving thermal shocks, where we heat the boiler and suddenly cool so that the scale would be powdered or crushed or cracked and removed from the surface of the metal. Then we can also go for treatment with acids, because acids almost dissolves all the possible compounds it comes in contact with. Similarly, we can use complexing agents so that they will complex with the salt and scale and sludge could be removed. So let us once summarize the session. So here, as far as exam point of view, we have to see the definition of boiler feed water. That is, water fed into the boiler is called as boiler feed water. Then another important is slide number 9, that is how scale and sludge formation takes place in general. That is, when the water is boiled, bubbles are created. These bubbles strike the walls of the boiler, and when the bubbles break, the salts would be start getting concentrated. When their concentration increases, they will be precipitating. And then two definitions, the scale and sludge, must be known, and the reasons for the scale formation. All four reasons with the reactions must be studied. Then the difference in the sludge, if mentioned, compared with that of scale, the subsequent reasons if you mention, that completes reasons for sludge formation. and disadvantages could be clubbed for both because almost scale and sludge poses same kind of problems for the boiler working. And 3 or 4 overcoming measures, if you know, it would be better. So the next discussion is about the second boiler problem, that is priming and foaming. We will be discussing about that in the next session. Thank you.